All right, everybody, welcome to the video here for lesson number 10 on density. So the opening exercise asks us to describe the meaning of density of an object. So take a minute, see if you remember what density means from earth science or wherever you learned density last. All right, so what is density? So density is a relationship between volume and weight, which usually we call mass in science. So here is the definition of density, which I'm sure you saw right away. Density is equal to the mass divided by the volume of a shape. So what density tells us is essentially, like we said, a relationship or a ratio of mass versus volume. So objects that are more dense are going to have a larger value here for the mass over volume. Objects that are less dense will have a smaller value there. So if you take two things that have the same exact volume but have different weights or different masses, they're going to have different densities. For example, if you were to take a 5-gallon bucket and fill it up with water versus filling it up with cement, they're going to have the same volume, but the cement is going to be way heavier than water, so the density of the cement is going to be way heavier or a larger value. So let's take a look at an example here of how we can kind of play with density. The formula itself is pretty simple, right? So we just have to kind of know how to use it. So it says a wooden cube has edge lengths of 6 centimeters and a mass of 137.8 grams. Determine the density of the cube to the nearest thousandth and state which type of wood the cube is made of. So if we have a cube, so nice thing about a cube is all of the sides are actually the same. So we have a 6 by 6 by 6 cube. The volume is length times width times height, and since all of those are the same, it's 6 times 6 times 6. So the volume of this cube is going to be 216. So then we say the density of this cube is the mass, 137.8, divided by 216. Type that in your calculator, and you get a density, which is about 0.638, which means this wood is made of ash. Pretty straightforward density question. So let's see what else happens here with density. So number 2 says a hemispherical water tank has an inside diameter of 10 feet. As soon as I see diameter, I'm thinking radius, because all of our formulas have radius in it. So the radius is 5 feet. Water has a density of 62.4 pounds per cubic foot. What is the weight of the water in a full tank? So to be able to use this density formula, we need to know the mass, which we know. Well, I'm sorry, which we don't know. We need to know the density, and we need to know the volume. So the first thing we have to do is find the volume of this hemisphere. We've done hemispheres a few times, so I'll just put the formula down here, right? Volume of a sphere divided by 2. So the volume of a hemisphere for this water tank is going to be 4/3 pi times 5 cubed divided by 2. So let's take a look how we type that in the calculator. So in our calculators here, if you have the new calculator, you can hit alpha y equals, hit enter, and you get a nice little fraction button that pops up here. You can even do that again for the 4/3. All right, so you do 4/3 times pi times 5 to the 3rd power. And that's all divided by 2. So I'm typing it all in my calculator all at one time. If you have an older calculator, do the numerator first, hit enter, and then divide it by 2. So we have 261.799. So we have a volume of this hemisphere is 261.799. Not my answer, so I don't want to round it yet. Now, we know the water density is 62.4, so density is equal to mass divided by volume. The density we know is 62.4. We don't know the mass or the weight, but we do know the volume is 261.799. This just becomes a proportion, so we cross multiply, and we get mass is equal to 62.4 times 261.799. So if I take that value I have in my calculator and I multiply it by 62.4, we get this mass, and it wants us to round this to nearest pound, so 16,336. Number three says a contractor needs to purchase 500 bricks. The dimensions of each brick is 5.1 centimeters by 10.2 centimeters by 20.3. That should say centimeters. That O shouldn't be there. And the density of each brick is 19,200 kilograms per meter cubed. Notice kilograms, centimeters, meters, centimeters. We have some different units of measurement here. So we got to kind of make everything into terms of meters. So we know 1 meter is equal to 100 centimeters. So if I take my dimensions, if I take 5.1 centimeters and I divide it by 100, it's going to become 0.051 meters. If I take the next one, 10.2, and divide it by 100, I get 0.102 meters. And if I take 20.3 centimeters and divide it by 100, I get 0.203 meters. That conversion is something that they consider, the Regents exam considers common knowledge, something you should know. So if we find the volume of a single brick, it's length times width times height, so 0.051 times 0.102 times 0.0203. Type that all into our calculator. That you could do without me uploading my calculator there. Just type it in. We get the volume of one brick in terms of meters is going to be 0.001056. Very, very small because we're talking about a brick and we want to put it in terms of meters, like a yardstick size. It's going to be a small number. Now, the thing is, there's not just one brick. There's 500 bricks. So we need to find the volume of 500 bricks, right? So to do that, we can multiply this by 500. That would give the volume of 500 bricks. Or we could just use the density of one brick to find the mass of one brick. Again, just like we did on the previous problem, cross multiply. So this would be the mass of one brick. Is going to be whatever that number is in your calculator times 1920. So one brick is going to be 2.028 kilograms. Now that's for one single brick. So if I take 500 bricks and multiply it by this mass of one brick, I can see that 500 bricks are 1,013.77 kilograms. Meaning the trailer will not hold 500 bricks because the trailer can only hold 900 kilograms. All right, moving right along. So during experiments, same type of bacteria is grown in 2 petri dishes. Petri dish A has a diameter of 51 millimeters. We want radius, so that's going to be 25.5. And the other one has a diameter of 75. All right, divide 75 by 2, we have 37.5 for my radius. Again, we always want radius. As soon as I see diameter, I want radius. So it says determine the population density. So each one of these petri dishes has a certain amount of bacteria in it. The population density is the population, kind of like any population. So if we wanted to find the population density of Cornwall, we'd want to find the area that Cornwall is and compare it to the number of people that live in Cornwall. We're doing the same thing here. We're going to compare the area of each petri dish and the number of bacteria that are in that petri dish to figure out how many bacteria per millimeter squared that we have. All right, so population density is kind of like the density formula, right? So we're going to say the population divided by the area. So to find the population density, we need to find the area of each of these shapes. So the area of a circle is pi r squared. So the area of this smaller petri dish is going to be pi times 25.5 squared. So if we type that in our calculator, we can approximate that answer. So we'll say pi times 25.5 squared. It's going to be a relatively big number. 2042.82. That's good enough. Area is pi times, in this case, the radius was 37.5 squared. So we'll type that in our calculator. And we get an area of 4,417.86. So to find the population density of A, we're going to take the total population of A and divide it by the area of A. So if I take 40,000 bacteria and divide it by 2042.82, I get a population density of 19.58. If I find the population density of B, I would take the population of B, bigger petri dish, more bacteria, and divide it by the area of B, too many fours, there you go, and see what the population density comes out to be. So divide those two numbers in your calculator. Again, do it with me, so make sure you're getting the same answer. And we get a smaller number. So it states which petri dish has a greater population. Petri dish A has a larger population density, meaning there's more bacteria per meter squared in petri dish A than there is in B, right? Kind of like if you were to compare the two towns, Cornwall versus Newburgh. Newburgh is a larger square footage area than Cornwall, but there's less people that live in Cornwall versus Newburgh. So Newburgh is going to have a higher population density than Cornwall is because there's just more people that live there. Okay? And then we can move on to our homework questions using density. The density formula is not on the reference table. It is something that you do need to know how to do. All right, so that's something that is a memorized formula for us. Again, when you're doing your homework, make sure you do the questions first, then watch the video, see if you do them the right way. All right, that's the best way to do it. All right, hopefully this video helped, and I will see you soon.